Hello my dear students, and this is your Kiran, and today in this video we are going to look into a very important topic in physics, that is ray optics. Why I say this lesson is very important is like when you appear for any competitive exams like NEET or JEE or whatever it may be, you can find a quite few number of repeated questions from these chapters, that is wave optics and ray optics. They are completely interrelated to each other. So I would say that this is the key chapter in higher grade physics. And today in this video, I'm going to crack how to derive mirror formula and lens formula. First, I'll derive a mirror formula, and then another video I'll derive a lens formula. Why I have chosen these two topic in the sense because after having conversation with n number of badges, students they used to tell that these are the two topics they find it very difficult to understand, and also they don't know how to apply mathematical relations to derive mirror formula. In lower grades, in grade 10 we might have used this mirror formula and lens formula directly by applying given data from the question, and we would have found object distance, mirror image distance, focal length, and so on. But here it is not like that. We are going to derive the formula itself. So it takes quite a few time, but it is very easy once you look into this video completely, and make sure that you're sitting with your pen and paper when you're watching this video, especially because you should write and see only then it will be very easy for you to understand. And if not, because I'm going to derive mirror formula using a concave mirror, and obviously you have to try with your convex mirror. Again I'll be doing with convex mirror. Here you can get a question anyway. For concave and convex mirror, the formula is going to be same, right? Why you are deriving it separately? To verify whether we are getting same formula for both the mirrors, we are going to verify it. So that is the reason, not more than that. So let's verify and derive the mirror formula. So here I have chosen a concave mirror. Concave mirror, it is also called as a converging mirror, because when a parallel beam of light is made to fall on this concave mirror, after reflection it converges the light and makes the light to fall on a single point called as an focus. So this mirror, it is called as an converging mirror or concave mirror. And another important point that has to be taken into consideration is like out of six ray diagram, six rules, first five rules will get real and inverted image for concave mirror, except one, the last rule. This is the point where students are repeatedly making a mistake when they were asked to draw a ray diagram for this last condition. Okay, fine. So here we have drawn a concave mirror with a principal. See, this is the pole, center of the mirror. It is called as a pole, and from there I have marked a focus, and with the equal distance I have marked center of curvature. Okay, so let's. I'll use different colors to make it quite easy for you to understand. So here it is like, let's take, we have nearly four rules to draw a ray diagram. Here we can choose first three rules. Okay. Here I'm considering an object which is, here I'm considering an object which is placed beyond C. Since I'm using a stylus, drawing a perfect ray diagram is not possible. But when you're drawing with your pen and paper, please make sure that you're using your scale and pencil, because it is not like when you're drawing a circuit diagram or other diagrams from physics, it is not a matter. But when you're drawing ray diagram for ray optics and wave optics, it is very mandatory to use your scale and pencil so that you'll get a perfect ray diagram. Okay, here I have chosen an object. I have placed an object which is beyond center of curvature. Let's mark this object as OO dash. Okay. Now light rays. So light rays falls on it. We'll take three rules. when light ray is parallel to the principal axis, this is called as a principal axis. The line which is joining center of curvature, focus and pole, it is called as a principal axis. See, each and every point I'm explaining it. Please make sure that you're listening very carefully. Okay, so the line which is parallel to the principal axis, it is called as an this is the incident ray. So when it is parallel to the principal axis, after hitting the mirror, that is after reflection, the reflected ray will pass through focus. The reflected ray will pass through focus. Okay, and next I'll take another rule. Suppose if the incident ray is through focus, what will happen? Or if the incident ray is through center of curvature, what will happen? Let's take incident ray through center of curvature. See, the incident ray from an object is through center of curvature, so that I have to extend this mirror. There's no other go. Okay, if it is through center of curvature, after reflection, it will retrace its own path. Okay, this is the rule. This is the second rule. And third rule is that if the incident ray is exactly on the pole, so it will undergo an reflection at an equal angle. That is, incident ray will be always equal to reflected ray. I'll use a different color here so that you can identify three rules. I hope this is visible. Okay, this is incident ray, and after reflection, that is equal angle. It should reflected at an equal angle. Okay, so these are the three rules I have chosen. So all three rays meet at a point called as an, I can mark it as I dash. Okay, so this is the point where image is formed. Image is formed. Okay, I'll mark it with the black. Image, this is the image. Okay, so this is real and inverted image. See, the object is erect here, but the image falls on the same side of the object, but it is inverted. Okay, this is I. Fine. I have made all markings here. Let this be A. And is this anything left here? I think everything is okay. Okay, let's get into the mathematical part here. How to derive a mirror formula using a concave mirror. So we have drawn a ray diagram. Out of 4 rules, we have used 3 rules, and we have marked the image, that is real and inverted image. Okay, let's take a right angle triangle here. Right angle triangle. What triangle we can take it here in the sense? I dash P. I dash P. Look here. I I dash and P. Okay. This is this is one triangle. I'll draw it here. Each and every segment I'll separate and draw it here so that you won't find it very clumsy to look into the same ray diagram. So this is I dash P. Okay. And next is O dash P. O dash P. So like it will be here, right? With the same base, it shares same base with the triangle. So this is O dash P. O dash, and this is P. Okay. So here we have chosen two right angle triangle which are sharing their base with one another. So this is O dash P. Okay. So according to congruency of triangle, we can say that sides of the two triangles are in equal ratio. That is, look here, I dash. See, this is the image. This is the triangle of the image. This is the triangle of the object. So always make sure that you are putting opposite side of the image divided by opposite side of the object. So opposite side of the image I have written, and opposite side of the object is here O dash, which will be equal to adjacent side of the image divided by adjacent side of the object. So here adjacent side is like IP. So this is IP divided by adjacent side of the object is, here it is OP. Okay, it is over. So here you can say that similarly right angle triangle I dash F and APF are also similar. So A is very close here. Let me tell a point here. That is, even though here you can find a curved path from A to B, you can draw a perpendicular line. You can draw a perpendicular line, making it as a right angle triangle, because even if you draw this, it is not going to bring a big change in the answer. So you can neglect this a small curvature. You can make it as a flat. So that is the reason why I have drawn a perpendicular line here. Now I am going to take another two right angle triangles. Look here, other two right angle triangles. The first one is I dash F. I dash F, and another one is A P F. Let me draw those two triangles in a segment. I dash F. This is I dash F. I dash F. Okay. And next is APF. APF is continued here, right? This is APF. See here we have a small curvature. This can be neglected. To make it as a right angle triangle, we have to do this, but it is not going to reflect in your answer. You will be getting a perfect answer. Okay, no issues. So this is APF. So what I told, image opposite side, this is image triangle and this is object triangle, right? So what I'm going to do here is like image opposite side, that is what is image opposite side? I dash. I dash divided by, and object opposite side, that is AP, which is equal to image adjacent side by image opposite side, adjacent side. So I have drawn here, right? And look here, AP and OO dash are equal, right? AP and O. See, look here, AP, this AP and OO dash, these two distance will always be same, right? So OO dash is equal to AP. So instead of AP, I can write OO dash here. So this can be replaced with OO dash. Okay. So I'm considering this as equation number one and this as equation number two. So let me compare these two equations. When I compare these two equations, on equating these two equations, what will happen? These two terms will completely eliminated and rest of the things will come here. IP divided by OP is equal to IF divided by PF, right? So this is the final equation here. So here instead of IF, instead of PF, sorry, IF, instead of IF, I can replace it with, instead of IF, look here, instead of IF, I can replace it with IP minus FP, right? IP minus FP. Look here, total IP minus FP, I'll get the distance between image and the principal focus. Okay, so here it can be replaced. So the same equation can be rewritten as IP divided by OP is equal to IP minus FP divided by PF. Okay, so let me clear this. I'm going to clear the whole screen. Okay, I think you are clear till now. Fine. So, what was the last equation we have written? Like I didn't even I forgot to note it down also. Like IP divided by OP is equal to IP minus FP divided by PF, right? So this is the thing. So what we are going to do is like, and we know object is always placed on the left side. So if this is the object, if O dash is the object, what is the object distance? OP is the object distance, right? Right from the lower grades, we might have learned this. So OP is nothing but object distance U. Since object is always placed on the left hand side, it should be marked with an Cartesian sign of minus U. And next is where the image is found on the same left hand side. So the image distance, that is IP is image distance. IP is equal to V, since it is on the left hand side, that is minus. And the focal point of this mirror is the focal point, you know that the distance between F and P is called as a focal length. So the focal point F and P pole, which is equal to focal length F, even this is minus, because even this comes in the imaginary part of the, see, if you draw an imaginary sphere, so the focal length comes on the left hand side of the quadrant. So even this is F. I'm going to substitute all these values in the above equation to get this mirror formula. So if I apply all these values here, what will be getting? Minus V divided by OP is minus U is equal to IP is minus V, and FP is minus F divided by, and FP is minus F. So B divided by U is equal to minus V plus F by minus F, and here I am going to take this minus out. So minus V minus F divided by minus F. So it get cancelled. Let me split this into two terms, V divided by F minus F divided by F. So in order to obtain mirror formula, let's consider this, that is I'm going to divide by U on divide by V on both sides. See, both the sides I'm going to divide by V. So when I divide, so VV get cancelled, VV get cancelled, and here F and F get cancelled. So what we'll be getting is 1 divided by U is equal to 1 divided by F minus 1 divided by V. I have to rewrite this, right? This is not the formula that you have learned in your lower grades. So it will be quite simpler, right? So I'm taking to that level. That is, I'm going to bring this minus 1 by V to the side. So 1 by F is equal to 1 by V plus 1 by U. So this is the mirror formula we have derived using a concave mirror, using a few trigonometrical ratios, geometrical ratios. Okay, I hope you are clear with this derivation. And even if I use a convex mirror, I'll be getting the same answer, and I'm going to derive that in another video. And please do watch that video, or without watching it, please try to derive using the same methodology, same triangular ratios, and everything is same. But make sure that you are getting an exact answer with same Cartesian sign notation. Okay, fine. So I'll get you back in another video, unless it is bye from your Kiran. Thank you.